So when you analyze a data set with one or more random variance components, you will see that under the Effect Details tab, under Model Details, the table will appear slightly different than the one you would get if there were no random components in the model. Now, the big difference is that here you have a new column, which is for the degrees of freedom, and these degrees of freedom in a traditional ordinary least squares analysis without random variance components is exactly the same for all fx. However, with random variance components, these are different for different effects and can sometimes be fractional. Now, due to the presence of random variance components, other than the residual variance, it is possible that certain effects are estimated less precisely, and that is exactly what is reflected by these degrees of freedom. So if the degrees of freedom associated with certain effects is quite small, then we have less information, or our data set has less information about these effects, and if it's large, then our data set has more information about such effects. So if I look at the table over here, we see that for this effect, I have 26.93 degrees of freedom. That's the estimate or the coefficient. And this is the bound for that coefficient. And you see that it's quite narrow. Now, on the other hand, here for the main effect of x6, you see that the degrees of freedom is quite small. And therefore, this window or this confidence interval that we have for the coefficient is also quite wide, and that is what you can expect with random variance components if these or if certain effects are not estimated as precisely as others. One thing to add here is that apart from the different degrees of freedom for different effects, everything else should look also similar to the table that you would get from a regular analysis without variance components. You have the same columns for the coefficients, standard error, the confidence interval, lower and upper bounds. With these columns over here, you have a t-statistic and the p-value. And the p-value takes into account these varying degrees of freedom for the different effects, so these statistical tests are accurate as possible.